All right, welcome to section 9.2. What we're going to be talking about today is an ellipse. So in the section, we're learning about the properties of an ellipse, and we're going to be doing a lot of the same type of work as what we did with a parabola. Really throughout all of chapter 9 and throughout all of the topic of conics, we do have to know that algebra skill of completing the square. It's going to be super, super important, not just with the parabola, but also with the ellipse and with the hyperbola. So you'll get familiar with a lot of that. We're still going to talk about something like focal length. We'll still talk about like a center and some vertices as well. But obviously they have different shapes and different unique properties based off of what type of conic we're working with. So first, to actually define what are we talking about when we talk about an ellipse, please make sure that you do draw in this picture. It's going to be important for you. But an ellipse is the set of all points, x comma y, in a plane, the sum of whose distance from two distinct fixed points, which we call foci. I'm not sure if that's pronounced foci or foci, and it's always sort of like a contention where I say foci sometimes and then I say foci, and some people say like foci and foci. Don't say that, that's not right. But if you say foci or foci, either one of them is fine. Honestly, I think it's foci, but it reminds me of Loki from Thor, so then I usually switch to foci. But anyways, back to our ellipse. So it's the set of all of the points, x comma y, so all these coordinates, where the sum of the distances from two of these foci is the same. So here in our picture, you can see that there are two foci. I guess we're going to have to keep saying that word. There is a focus over here and a focus over here in the ellipse. What happens with these points that make the ellipse is no matter what point I pick, we'll just call this x2 comma y2. If I make this distance 1 and this distance 2, no matter what point I pick, the sum of these distances, or the sum of these distances, it's always going to be a constant. Unlike a circle, well, you're going to see this formula, but unlike a circle, it's not really called a radius because it's not a single center. And we do have a center in an ellipse. All right, so two standard forms, just like with the parabola, we have two different standard forms for the equation of an ellipse. So we have x minus h squared over a squared plus y minus k squared over b squared equals 1. Or we have x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Now notice the only thing that's really happening here is the a and the b are switching locations. That, however, tells us the shape of this ellipse. So you might be thinking like a parabola, we had two different equations because it was either going to go up, down, or it was going to go left, right. But you have the same thing with the ellipse as well. This ellipse is an ellipse that's going sort of long ways. And this ellipse is an ellipse that's going more tall-wise. That's a terrible ellipse. I'm a terrible artist. Sorry for everybody. Now, h comma k, just like everywhere else, it represents the center. In this case, it is called a center. It's not called a vertex. So h comma k is the center of the ellipse. Whatever I get for a, twice a is the length of the major axis, the major axis being the longer one, and twice b is the length of the minor axis, where b must be between 0 and a. This sort of naturally would occur. That's just telling us that the minor axis has to be smaller than the major axis, but can't be 0 or negative. So something to keep in mind about this, whichever one of these is the larger one is a. So a is the larger. And A is really what determines which way this oval goes, so horizontally versus vertically. So A determines the direction of the ellipse. Sorry, I called it an oval. So A being underneath the x term means that this is going to sort of lay out horizontally. So the length will be horizontal. A being under the y term means that the longer part of this is the vertical. All right, so again, we have these two pictures. Here, I have an oval that's laying out horizontally. The longer part is horizontal. We call that the major axis. The major axis is the one that's the longer one. So I have my major axis being the horizontal, h comma k being the center. Notice this equation, the a squared is underneath the x term. And again, that's what tells us that the major axis is the horizontal. On the other hand, when a is underneath y squared, that tells us that our major axis is the vertical, and hence we're going to have an oval that's more sort of narrow and tall. The foci, foci, wherever, the foci lie on the major axis, so they're always on the major axis, whether or not that's horizontal or vertical. And it's c units from the center. Think of c as still being your focal length. So it's not p like it was with a parabola. It's c for this. And the formula for this is a little bit different. Notice c doesn't actually show up in the equation. So to get c, we use the equation c squared equals a squared minus b squared. This is going to be extremely important to remember because pretty much every question you're going to have to find the two foci. So you have to know that equation. And in a hyperbola, just a preview for section 9.3, you get this same sort of equation. It's just that it will change to a plus. So you need to make sure that you know the ellipse is the one where I subtract, as where the hyperbola is the one where I'm going to add. All right, so the only other thing that we talk about with an ellipse is the eccentricity. The eccentricity, and I'm not kidding about this definition, is really like the measure of the ovalness, and I just did air quotes even though you can't see them, but it's the measure of the ovalness of an ellipse. Another way that you can sort of think about it is that how ovally, or if you wanted to be a rebel, you could think of like how close to a circle is it. So that's the definition that we could sort of think about. But technically speaking, if you wanted the mathematical definition, it's really the ratio of the focal length to half the major axis. And the formula for this is just E is equal to C over A. So an E value, that's very small. When there's a small ratio of focal length to half the major axis, that means that this is going to look more and more like a circle. E always has to be something between 0 and 1. An E value of 0 would mean this is a circle. And then if E is closer and closer and closer to 1, you get something that's going to look more and more and more ovally, or have more ovalness to it. Eccentricity. Man, it's the best definition. All right, so we are going to do two examples, and it's just, to give you a little bit to relate this to. And then hopefully if you want, you can get started on some of that homework because you'll have sort of a preface to go off of. So we're going to go over two questions where we go through center, vertices, foci, eccentricity, and we're going to sketch it for you. All right, so follow along with my mentality. Find the center, vertices, foci, eccentricity, and sketch. Now, first thing I'm going to look for Is this in sort of the completed the square vertex standard form of an ellipse? And in this case it is, because we have it in the form of x minus h squared plus y minus k squared equals 1. And then we're concerned with those things that it's over. Remember that the larger one, so here I have my larger one, that tells me that this is a, because a is always the larger one. So we have a squared equals 169. So we have a squared and b squared. Again, knowing that a squared is underneath the x term tells me that this oval has a major axis that's horizontal. Again, terrible art skills. Let's just try and fix that a little bit, actually. That was really bad. Okay, that's a little bit better. Yeah, I like that better. So we know we're going to have some ellipse that looks like this. If a squared is equal to 169, square root both sides, I get a is equal to 13. You don't have to worry about the plus or minus in this case. And then here I know that b squared is equal to 25. So b is equal to 5. In terms of my center, your center, remember, let's just change the color to help us out a little bit. Our center is in the form of h comma k. So here there's nothing being subtracted for x, there's nothing being subtracted from y, so our center is 0 comma 0. So over here I'm just going to draw a little sketch of what's going on. There's sort of a lot of work that goes into these questions, but don't worry, you don't end up getting a ton of them. So we have our center here at 0 comma 0. We know we're going to have some oval that's going like this. I'll label this 0 0. Now, the a value of being 13. This tells you how far you move along your major axis. So that means starting from my center, I will go 13 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'll have 13 comma 0. And 13 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is a good song. So I'll have negative 13 comma 0. Ooh, that is a terrible 13. Okay, well, that says 13. It was better before. The b value tells you how far you move along your minor axis. So starting at 0 0, I'll go up 1, 2, 3, 4, 5. And have 0 comma 5. And down 1, 2, 3, 4, 5. And have 0 comma negative 5. Those are our vertices, by the way. So we have 13, well, plus or minus 13 comma 0, and 0 comma plus or minus 5. I think a lot of the questions in the book, when they ask for vertices, they may not list these minor vertices. They might just actually ask for or list the major vertices. So just be familiar with that. It's one thing that the book sort of differentiates from what I would say. And then looking at our foci conundrum, remember that the focus here is not the vertices. There is some focus, well, some two focuses, some two foci, along this major axis, and that's what I have to find. I find that by finding the focal length. So focal length, where's pink? There we go. Uses the formula c squared equals a squared minus b squared. So c squared is equal to a squared is 169, b squared is 25. So c squared equals 144, and c is equal to 12. Great, so we know how to find c, but what is that actually telling us? That's the focal length. So that's going to tell us, starting from the vertex, along the major axis, how far do I move? So I move 12, which is right here before 13, 12 comma 0, and I move negative 12, which unfortunately took up 2 spaces, to negative 12 comma 0. I've got everything that I need now to draw this oval. Sorry, ellipse. I keep calling it an oval. It's not an oval, it's just ovally. And don't criticize my art skills, only I get to do that. Wow, okay, let's try that again. Okay, great. Yeah, that's sort of what an ellipse should look like. Last thing we have now is eccentricity. Ooh, we're eccentric. Let's do 3 because otherwise it looks like a smiley face. So eccentricity formula, remember that is just E is equal to C over A. Now remember that eccentricity, what that is a measure of how ovally our ellipse is. And in the case of what we're looking at here, we would be thinking like, this is pretty ovally. So I'm expecting an eccentricity that's sort of close to 1, because close to 0 means it's relatively circular. So we're going to have E is equal to, C is 12, A is 13. So it's 12/13, which comes out to approximately 0.923. So, pretty ovally. All right, we got one more example, same type of question, just to give us a little bit more practice with this. So find the center of vertices, foci, eccentricity, and sketch a graph. Now looking at this one, you can see here the larger number is underneath y. This right here tells me this is a squared. This is b squared. And the oval must be going vertically. Has to be going vertically again because that larger number is underneath the y. That's only for an ellipse. When we see a hyperbola, we're going to see something else where different things change. So our center here, remember this is x minus h, so h is 1, and y minus k, so k must have been negative 2. We go over here and we can start making our sketch as we go along that. Wrong tool. I know, there's not a lot of room for this. All right, so 1 comma negative 2. And we're just going to label that point 1, negative 2. Yeah, we'll label it now. 1, negative 2. Sometimes I wait to do the labeling only because we don't know what other points we're going to have. So we don't know how condensed this oval might be. But I've already done the question, so I sort of already know. So vertices. If I want these vertices, remember that starting from this center, I go A units up or down and B units left and right. So A, since A squared is equal to 100, A is equal to 10, and B is equal to 8, coming from B squared equals 64. Again, the larger one goes with my major axis, and my major axis in this case must be the y's. So starting here, I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will put me at 1 comma 8. And then I'm going to go down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To put me at 1 comma negative 12. Next, I'm going to go left and right, 8. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. Did I just count that wrong? 1, 2, 3, 4, 5, 6, 7, 8. There we go. And have 9 comma negative 2. And 1, 2, 3, 4, 5, 6, 7, 8. To have negative 7 comma negative 2. All right, so we can sort of see the ellipse that's happening here. Vertices, then we can list them right away. We had 1 comma 8, 1 comma, whoa, okay, let's go back. I just tried to make that one really big coordinate. 1, 8, and 1, -12. These were my major vertices. My minor vertices would be -7, -2, and 9, -2. For our foci or foci, we need the c value. So c squared is equal to a squared minus b squared. We know that a squared is 100, b squared is 64, c squared is 36, so c is 6. Again, this is our focal length. And what our focal length is telling us is starting at our center, how far along the major axis do we move in order to get to our focus? So starting at our center, our major axis was the vertical, and we're going to move 6. 1, 2, 3, 4, 5, 6. This is 1, 4. And then moving down, 1, 2, 3, 4, 5, 6. This is 1, -8. Now we can draw the ellipse that goes through all that. So we're starting and just really going along those outside points in the most ellipse-like shape we can. Mr. Diamond, oh my God, I am terrible at this. Man, I hope that you guys are a lot better at me, or than me, at drawing ellipses. I guess I'll just do it in pieces. That seems like it's working out better. I promise I won't ridicule your artwork. But I mean, I'm going to say that's pretty good. Okay, so now eccentricity. Again, you're thinking like, eccentricity, that's the ovaliness. And when I'm looking at this, I'm like, that's not too ovally. Now, this does look more circular than it should, and that's just the nature of me not having the same amount of distance between all of these. Like down here, that didn't probably go as far down as it really should have. This probably didn't go up as high as it should have, so it's probably a little bit more narrow, but we can find out exactly how ovally this is. So we have E equals C over A, nice little itty bitty formula. C is 6, A is 10, so we get E is equal to 0.6. 0.6, that means it's like, well, I mean, it's not a circle, but it's not super ovally. It's somewhere just sort of in the middle between what you would define as those two things. All right, the next 5 slides we'll be going over in class. I think 5 slides. Yeah, next 5 slides we'll be going over in class. They're just more examples, different types of questions. A lot of them sort of relate to the types of questions that we've done with a parabola, where I can give you different pieces of information. So in this case, I gave you the equation, but in other cases, I can give you the vertices, and you have to come up with what A is. Or I could tell you where the focus lies and where the center is, and that gives you the focal length, and that can help guide sort of how you're going to move through that question. So take your best guess on some of those starting homework questions, maybe just look them over, see if you'd be able to get started on them. And then again, looking through these notes, if there was a part where you were like, I have a question on that, and I can't ask right now, obviously, because you're just listening to a recording, just jot it down, write on your notes, maybe put a little star, highlight it, however you want to do that. And then we'll start off with those questions before we do the examples.